Everybody say hi to Claire and all the cross-country people.
Hi, Claire and all the cross-country people.
That was a lot of stuff to say. Okay. All right, we have a small class. There's like 5 of us in here. So, linear programming sounds really intimidating of a word, or 2 words, I guess they are. But it's not too bad. When you are doing linear programming, you are finding a maximum or minimum value, and you are given things called constraints. Okay, so if I am like a research and developer for a company and I am trying to minimize cost and maximize like profit, that is my job. That is what I'm trying to do. The constraints that I'm given is like the materials. So maybe we are producing shoes and I have a limited amount of materials to make those shoes, like the rubber that goes on the bottom of your shoes or the laces or things like that. I have a limited amount of materials and I want to get the most profit with the least amount of cost, okay? And that's kind of what we're doing for this section, okay? So we have equations that we are going to, like lines that we're going to graph. And then what we're doing is we're finding the vertices of those like equations. So the places where those lines cross each other. So if you have a triangle, you're going to have 3 vertices. If you have, this is an unbounded region where we only have 2 vertices, and then he's kind of unbounded on the other end. He will be shaded all the way down. Those vertices we're going to end up plugging back in somewhere to see which one is the maximum or the minimum value. So we've already done some of this before. Example 1, they give us these 3 equations that are constraints. These are my 3 constraints. And then this is like my profit equation. Okay? This is like my equation for profit. Okay? That f of xy. We're going to deal with him last. So kind of just sit tight and hold on to him for just a little bit. We're not going to use him right away. We're going to graph the other 3 things first. And this top one, where it says 3 is less than or equal to y, which is less than or equal to 6, I'm actually going to split him into 2 pieces. Okay? So if they say 3 is less than or equal to y, that's another way of saying y is greater than or equal to 3, right? If I write this guy, but I flip him around, that means y is greater than or equal to 3. Does that make sense? Okay? And then I have y is less than or equal to 6. We have those things going on. Okay? And then we want to graph them. So how do we graph like y equals 3 and y equals 6? What do those look like?
Lines.
Like straight lines. So I go to 3 and I draw a straight line, and he's a solid line. And I go to 6 and I draw a straight line, and he's a solid line there as well. Okay? And y is greater than 3 and less than 6, so the region that I'm shading is between them. Right? Greater than 3, less than 6, that's that shaded like tunnel in between them. Okay?
Technically,
what?
The whole thing is shaded, but that is shaded darker.
Kinda, yeah.
Because above the line.
Right. Yes, exactly. Yes, I see what you're saying. Because above 3 is still considered like this section up here, and below 6 is this. But that's like the region that's double shaded. That makes sense. Yes, I see what you're saying. Okay, so this next one, y is less than 3x plus 12. We've got to start at 12. Oh my gosh. Mine doesn't even go up that high. 11 is right here at the top of that arrow. 12 is like on the T. Okay? And if I go up to 12, the 3x means I go up 3 and over 1, but I can't go up any higher. So I go down 3 into the left one. If I go down 3, where will I be located at? I'm at 12 now. If I go down 3, I'll be at 9 and over 1. So this guy right here is at 9, 1. Does that make sense? 9 and over 1, go down 3 again and over 1. He's going to touch right there at 6. Does that make sense?
Yeah.
Okay. Down 3 over 1 again, down 3 over 1 again, blah, blah, blah. He looks like that. He's a solid line again. Now, which way do you shade that solid line? Do you know? Which way is that going to be shaded? Y is less than.
So below it.
So he's going to be shaded this direction. He's going to be shaded this direction. To the right and down-ish. Okay. The last one, I'll do it in blue here. Starting at 6. 6 right here, and I go down 2 and over 1, and down 2 and over 1, and down 2 and over 1. That's what this guy looks like. And I connect my dots and just hope that it looks nicely. Something of that nature. Oh, perfect. you.
But I
Yes,
got
that's
you.
fine.
Okay.
Yep. Thank you.
Yes.
Okay, so, and that one is less than. So that one is shaded to the left and down. So which region is like quadruply shaded?
I have no
Like-
idea. I can't even see it.
Like 0, 6.
Like this region right here.
Yeah, that.
I can't see it.
That region-y guy.
It hurts my eyeballs.
It hurt your eyeballs. Okay. This guy, do you know what shape that is?
It's a
triangle.
It's not a triangle.
not a
It's a
triangle.
square.
No, it's not a square.
It's
A rectangle.
It starts with a T though.
it's a
Trapezoid.
It's a
trapezoid.
trapezoid. Okay, so we are interested in finding these corner points right here where that trapezoid is located. Okay, so some of them are crossing really nice places, like this guy right here. What is his coordinate point?
0, 6.
Like 0, 6, you betcha. Okay,
Did I say it?
and this guy,
I
no,
don't know.
you didn't. You
Like
didn't.
2.
He said like, and you said the answer.
Like 2, 3.
Which one? Oh, the bottom one, right here.
Uh-huh.
He is not exactly at 2, 3.
Like 1.5.
Like 1.5, comma
3.
3. 1.5, comma 3. You know why I know? If this guy's up at 6 and we went down 2 and over 1 and down 2 and over 1, he's not going to cross right there exactly. Does that make sense? He's crossing at 1.5. So 1.5, comma 3. This one crosses really nicely though in this corner. What's he?
Negative
Negative
3.
2, positive 3.
That's a
I think it's a
Wait,
negative
I was
3.
looking at the.
Negative 3. Negative 3, positive
yeah.
3. And the one at the top is negative 2, comma 6. Is that right?
Yeah.
Okay, so those are the places that I'm looking at plugging in, okay? And what I'm going to do is after I find those corner points, I'm going to plug them into my profit equation here and here for x and y. Okay, so I'm going to list these out. Let's go 0, comma 6. I'm just going to go around in order the way that we did. 1.5, comma 3. I'm going to go negative 3, comma 3, and negative 2, comma 6. We're going to plug each one of those in. So I'm going to take 4 times 0 minus 2 times 6. 4 times 0 goes away. 2 times 6 is 12, so this guy is negative 12. Does that make sense? After we plug it in?
Yeah.
So we've got negative 12 over here. I'll zoom him in a little bit. Okay. 1.5 we're going to plug in next. So 4 times 1.5 minus 2 times 3. Do you know what 4 times 1.5 is?
Probably do, but.
4 times 1.5 is 6 minus another 6. So he is
0.
0. There he is. Okay, so that guy comes out to be 0 when we plug him in. Okay, negative 3, comma 3. If we plug 4 times negative 3 in, minus 2 times 3,
Negative 12.
negative 12,
and
minus 6.
Minus 6 is negative 18.
You betcha. Negative 18. Okay, 4 times negative 2, minus 2 times 6. This guy's negative 8 and negative 12. So
Negative 20.
negative 20. All right. Now we're done. Now we have to label some things. Find the maximum and minimum values of the function. So what's the maximum value?
0.
0. We just label him. This is our maximum. And what's our minimum value?
Negative 20.
Negative 20. Minimum. Okay. So this didn't have a story problem context to it, but if it did, let's say that like the X's were the number of shirts that I had to produce. Maybe I'm a Nike company. I'm producing X number of shirts and Y is the number of shorts that I'm going to produce for Nike. So I would have to, in order to maximize my profit, I would have to put 1.5 shirts and 3 shorts. And somebody said, how do you produce 1.5 shirts? Sometimes they will do this in millions. So it would be like 1.5 million, right? Okay. So you know, that's a scenario. We're going to have the third problem that we do is going to be our story problem, where we have actual context to this. Did that make sense though? Graph the things, find the points, plug them in, and see which one is the max and the min. Okay. This one is an unbounded region, but the procedure is about the same. We have these 3 constraints right here, and we're going to graph them. But the problem is one of them's not ready to graph.
Number 1.
Number 1, we got to take that top one and we got to fiddle with it. So let's do that over here. 2y plus 3x is greater than or equal to negative 12. Let's subtract the 3x first. So 2y is greater than or equal to. Can you subtract 3x from negative 12?
Yeah.
No?
Why not?
No. What was the question?
Can you subtract 3x from
No.
negative 12?
No.
Why not?
No, because it doesn't have an
Because
X
you
on it.
can't.
One doesn't have an x on it. Right. So negative 3x minus 12 is how we're going to write that. Okay, and then
That's fine.
divide by 2, divide by 2, divide by 2. So y is going to be greater than or equal to
Negative 3 over 2x.
negative 3 over 2x minus
6.
6. He is ready to go now. I'm going to circle him so we can remember which one we are graphing. Okay, so we're going to graph that guy. We're going to graph the second one in purple maybe, and the third one in blue. Who knows? We'll just do it that way
Why not green?
because I'm going to do my dots in green.
I don't like that.
Okay. All right, so the first one, we start at negative 6, and we go from there down 3 over 2. I'm off the grid.
No, up 3 over 2.
Up 3 to the left 2, up 3 to the left 2, up 3 to the left 2, etc. And I draw my line, and these are all going to be solid lines, right? Because they're all equal to.
Yes.
Okay, and he is shaded which direction? This guy right
That
here.
way.
Left.
Right.
That way, she says. That way. We're going to shade that way. I shouldn't do that. I should actually shade it because that's just going to be more confusing.
Just like at the very bottom, do that. So
Yeah.
So you don't have scribbles all
I know,
over.
I should do
Well,
that.
I do scribbles and it messes with
That's
my
right.
brain, so.
All right, second one I'm going to do in purple. We start that second one at 12. Oh, no. 12 is way off the chart.
Well, we're not going to do that then.
No,
Oh, we
well,
could do
okay,
that
so
six.
here's what we're going to do.
Negative
12 is
1,
all the way up here,
9.
somewhere. We don't know. But the 3 says I go up 3 and over 1, right? That's my slope. But instead I'm going to go down 3 and I'm going to go to the left 1. So if I'm at 12 right here and I go down 3, where am I at now?
Nah.
9. And I went
Yes.
down 3 and over 1. Okay? Now I'm going to go down 3 again. Where am I at now?
6.
6, and I'm going to go over 1. So here is where I'm at on the grid, right? Does that make sense? Down 3 over 1 again. Down 3 over... Oh, man.
That's nice.
That's real nice. That's
What a
real nice.
coincidence.
Good work, folks. Because he's crossing real nice.
Happy birthday.
Woohoo. Okay. I'm going to go ahead and mark him. Can we mark him?
I do not.
Because I like that
understand.
dot. They
Yeah,
cross at a real nice place. What's that real nice
dots
place
were
at?
green.
Negative 4, 0.
Negative 4, 0. We're going to label him. Because I'm so excited about them crossing
I
real
like
nice.
it.
Negative
I labeled that one too.
0, 0,
Oh, I forgot. We need to shade.
Oh, we need a shade. You're right.
It goes
It goes
left.
less than.
left.
So to the right.
Oh,
Right? Less than would be to the right.
yeah.
Okay. Last one that we have to do is 3x minus 6. Ruh-roh.
I hate this.
Look at these two equations that we just had.
What?
Look at them real close. Up real nice and close.
They're
What's that mean?
parallel.
Uh-oh, they're parallel. Okay. We're going to start at negative 6. Oh, there's a real nice place where they're crossing. Then I go up 3 and over 1. Up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, and they're never going to cross each other. Yikes. This is what's called an unbounded region. An unbounded region.
Like these.
That's not too bad. He is shaded inside of here, so the region that is triply shaded is this guy right here, keeping in mind that this shading will go up forever. But we do have 2 points where he is kind of like the boundary-ish, okay? So what we're going to do is pick on these 2 points. This guy right here is the point 0, negative 6. So what we're going to do is we're only going to plug those 2 points in. Just those 2 points and be done.
Why did we?
Okay? We're going to plug those 2 points in. So starting with negative 4, 0, and then we're going to plug in 0, negative 6. So there he is. Plug him into our profit equation. Maybe that's not profit. Maybe that's actual cost or something. I don't know. But we're going to find the maximum and minimum. Which one of those is a max? Which one of those is a min? So plug negative 4 in for x and 0 in for y. 9 times negative 4 is negative 36. Negative 6 times 0 is 0. So negative 36 is my number that I get with this one. Okay, the next one, I have 9 times 0 minus 6 times negative 6. 9 times 0 goes away. -6 times -6. What's that make?
Negative 30.
Wait a
Or
minute.
positive 36.
Positive 36. Whoa.
36, yeah.
Never mind.
Positive 36. So in this case, with this unbounded region, this guy would be my maximum, and this guy is going to be my minimum.
So it's 36 no matter
Instead of
what.
putting
One's
min,
-36.
with
One's
an
positive
N,
36.
I put mixed. Instead of min.
Oh, I just had a long day. All right. Okay, good. Max min. So in that case, with the unbounded region, we only have to test 2 points, which is kind of nice. Good? Happy with that? Not too bad. Okay, now they give us an optimization problem where we actually have stuff that we are doing. Okay? So they tell us that we have an electronics company produces 2 types of smartphone docking stations. They look kind of like this. Do you guys know, have you ever had one of those before? I literally have one of those sitting in my house right now. An iPhone docking station.
No.
You set your iPhone on it and it charges it, but it's also like a speaker.
I know what it is.
And people don't
but
have
I
those
don't
anymore
have one.
because they're all like the speakers are Bluetooth now.
Well,
like, they
we
don't
never
have a
had one.
charger area.
Like the iPhone 4s.
Yeah, these are like for really, really old iPhones, but I literally have one of
The
these.
Jimmy stuff.
And these are not very old. They're only like 7 years old, but technology changes so fast. Like, that's not very old.
The fitness.
Oh, come on. People, you make me feel old. All right, so what are the 2 types? We have 2 types of docking stations.
Right.
What are the 2 types called?
They're called.
What are the 2
I don't
types
know.
called? Look and see. What are the 2
Basic
types?
and multifunction.
Basic and multifunction. Which one is X and which one is Y?
Basic. Wait.
Doesn't matter.
Y is docking.
Which one is X? Basic multifunction. Which one is X? Which one is Y?
The purple one.
Multi-station. Multifunction. Is Y.
How do you know multifunction is Y?
What's so funny?
Because it says so on the graph.
Because it says so on the graph. Right here. This is how we know. Multifunction is the Y on the Y-axis. Basic is on the X-axis. Woo! So that's how we know. All right. Basic multifunction. All right. So let's write some stuff here. The minimum number of basic ones that we can have according to the chart is how many?
600.
600. So that means that X has to be.
800.
Hold on.
What?
If the minimum number of basic ones that I can produce is 600, that means X has to be what?
Oh. Or
Greater than or equal to 600. Okay? But the maximum number is 1500, so X has to be
Less than.
equal to or
less than or equal to 1500. Yeah, beautiful. Okay? The next one, let's talk about the Y's. The Y's, I'm going to use a different color.
It's Y and the same thing, 800.
Y has to be greater than or equal to 800 because it has to have a minimum of 800. Or Y has to be less than or equal to
1700.
1700. Beautiful. Okay? Now, there's one more thing that it talks about up here in the top. It says, if at least 2,000 items must be produced per shift. So that means the basic ones and the multifunction ones together have to be bigger than 2,000.
I know what that is. I actually.
Which is okay.
So what is that going to look like?
X plus Y is equal to or greater than 2,000.
You betcha. So X plus Y has to be greater than or equal to 2,000. That's what we're going to do. Okay? Now, the cost that it takes to produce each one, a basic, it costs $55 to produce, and a multifunction, it costs $95 to produce. Okay? So I want to minimize my cost. That's what it says up here. I want to find the minimum cost possible. All right? So we're going to graph all these inequalities, and then we're going to like put them. Oh, wait. Function to be minimized. So what determines my cost? I'll call this f of xy. That's how they labeled it up here. How do I determine the cost?
X times 55.
Okay, so we're gonna go 55x.
Yeah.
Okay, and then what?
Plus
Plus
95.
95.
Y.
Y. That's gonna determine how much my cost is, right? I multiply those together, and that gives me the total amount of my cost. Okay, so let's go up here and let's graph each one of these 5 equations here. Let's start with
Scary.
the x's. X has to be greater than 600. I'm going to do these in green like I have them over here. So x. Okay, so I go to 600 on the x-axis. We're going to go, each one of these is going to be 100. So
I don't
1,
have a number.
2, 3, 4, 5, 6. This is going to be 600 right here. And I'm going to go straight up and down. There's my 600. Okay? And x has to also be less than 1500. So if that's 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 is right here.
Then you draw in the middle of them, right?
And you draw in the middle of them. That's my shaded area. Okay, that's 1500. Okay,
Aw, dang it.
good, good, good. All right, the other ones, I'm going to do those ones in pink because that's what my y's are. Y is greater than 800 but less than 1700. So I'm going to go up on the y's. 1, 2, 3, 4, 5, 6, 7, 800 is here. And 9, 10, 11, 12, 13, 14, 15, 16, 1700 is here. Okay, so 800, draw a line.
That's
1700, draw a line. And now we have
draw in the middle.
this region shaded. So now we have a box. Well, we technically have this whole thing shaded, but doubly shaded is that little box on the inside. Okay, but there's one more thing that we have to graph, and it is this guy. X plus y is greater than or equal to 2000, but I can't graph him yet because why?
You don't know. Oh, they're not. The X is on the side.
The X is on the side. He is
So
invading.
minus X.
So we have to subtract the X over. So y is going to be greater than or equal to,
2000.
let's write the X first. Negative X plus 2000.
Yeah.
I always like to write it like that. It's not wrong if you read it the other way, but I always like to write it like that. Okay, so that means we start at 2000. 1700 is where I stopped up here, so this is 18, 19, 20. That's 2000 right there. Like right up by the little arrow. And the slope is what?
-1.
Down 1 over 1, down 1 over 1, -1. Okay, so if I go down 1 over 1, down 1 over 1, and all the way through, where's he going to end over here?
20.
He's going to end at 20 over there also, or 2000. So 15, 16, 17, 18, 19, 20, he'll be right there.
Again.
Okay, and I'm going to draw my line, and I'm going to do a real good job at doing this. I'm going to get my piece of paper here.
I don't know.
Okay, let's see if I can draw a straight line. There we go. Okay, that's good enough for me. Y is greater than, we shade up. So this region right here is the one that's like quintuply shaded. Do you know what shape that is?
No?
It's a diamond.
It's a kind of a diamond.
it's
Yeah.
not.
Yeah, it is.
Yeah.
Look at it sideways.
Fifth period, we had a huge argument. This is the Superman symbol. And they're like,
Oh, it
I
is.
don't see it. Chase Osdick, I don't see it.
Yeah, you look at
You're
it.
crazy. It's not a Superman. Yes, it is. Turn your head sideways. There it
Other
is.
way.
It's Superman.
I know.
Superman.
I'm
Turn your
being
head.
stupid.
Oh.
Okay. So there he is. We have that Superman guy. Okay, now this is a 5-sided figure, which means he has 5 vertices. This one, this one, this one, this one, this one, and we must find all of them. Yikes. So this first one right here, that's easy to find. What is his coordinate points?
It's 600, 900,
600, comma,
100,
I'll zoom in.
1700,
1700.
1700.
Yeah. 600, comma, 1700. Okay, this guy right here, this next one.
Something 1700.
Something, whatever that guy's. 15.
1500.
I wasn't zoomed out enough. 1500, comma, 1700. Okay.
And 1500.
This guy right here?
800.
1500, comma, 800. Am I going too fast?
Yeah, kind of.
Okay. I'll slow down.
1100.
Caden's staying right with me because he's not writing a darn thing down on his paper. That's good. At least you're following along.
It's 1100, 800.
You're sure?
Mm-hmm.
I don't think you're right.
No, it's not. It's.
We gotta find this guy right here. Now,
Yeah, that one.
I-
It's
it's
11.
something, comma, 800.
No,
Do
no,
we
it's-
agree?
It's 12. Is it 12?
Something comma 800. Now, this line right here that we drew, that slanty line,
Mhm.
says that x plus y equals 2,000. So if 800 is the y, what would the x be? That's going to live on that line.
What?
You see what I'm saying?
800.
I wasn't listening.
800 is the y
It's
coordinate
definitely.
that lives on that line.
It's 1200.
It's going to be 1,200. Does that make sense? Because it's got to live on that line, right?
Yeah.
Okay. Now, same thing for this guy. He is 600 comma something, right?
1200.
No,
What? No.
600 comma
Yes.
what? They have to add them together to be
Oh,
2,000 because this
1200.
line right here is 2,000.
14.
1,400.
It's just 14.
Okay.
Just
Does that make
14.
sense? Yeah.
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 Okie dokie. So now I'm going to take all those points. I'm going to rewrite them. Sorry, folks.
Part.
600, 1,700. You guys might need a calculator.
No, I'll just use my brain.
1,500. Yeah, you're going to need a calculator probably.
Are you
1,700. Yep. Yep.
Are we
Yep.
subtracting?
1,500. We'll divide and conquer these. How about that?
I'm not rewriting all those coordinates. It took me
You
like
don't have to if you don't want to.
forever.
I'm going to rewrite them though.
What
So
the
that
heck
my
are you
paper's a little
throwing
more
at me,
organized.
Alex?
And the last one is 1,200, 800. Okay? All right, so I'm going to take these guys. We'll divide and conquer these. Can we do that?
Yeah.
Okay, there's 5 of you. There's 1 of me. I can check you some of them. What we're going to do is this is the equation that we're plugging into. X
only
goes in
5
here,
of
Y
us.
goes in there. Okay, so who wants what?
I want
I want
the
number 1.
second
Take the last one.
You want the
I
last
number
one.
I want
You want the
third
first one?
Yes.
You want the third one? Second one or fourth? 2 or 4?
So what are we
2 or
doing?
4?
Cool.
4. Taylor's got the fourth one. You got the second one, Alec.
What are
Okay,
we
plug
doing?
them in. You're plugging in X and Y in for those guys. So this is your X, this is your Y. Whichever one you have decided, you have the third one. Plug them in and tell me what you get. So take 55 times whatever your X is, plus 95 times whatever your Y is, and you tell me what you get. I'll check them. 55 times.
Is it like 158,000?
Probably.
I got
You are the second one.
194,500. I should probably write that down.
First one? Who's got number 1?
Me. Oh,
Is that what you got?
yeah.
Yeah. Okay.
Because I can math sometimes.
I don't
She can
think I
math
can math
sometimes.
because I got less than that, but my numbers are bigger than that.
Uh-oh. You didn't type it in right.
Definitely not. I still think.
Check me. Who had number 2? Alec?
Yes.
Is that right?
244,000.
Did you really get that?
That's why I said it. You have it written down.
Caden?
Maybe. Well, yeah, I had that. Which I'm confused because both of those numbers. Oh, yeah, I did have that. I was just confused because I thought those numbers were bigger than.
1,700 is bigger than 1,500.
Yeah, I didn't
But
see the
the
17.
large, you have the larger number in for the 55 and the smaller number in for the 95. So that's why. Okay, and I gotta see what we got going on here. 6, delete, and 1,400. Moment of truth. Taylor, is this you? 166.
Did
You
get that
betcha.
knowledge?
All right.
Like just
Are we trying to maximize or minimize here?
Maximize.
Wait. Minimize.
We're trying to minimize because this is my equation for cost. Do you see minimize up here?
Yes, ma'am.
Minimize cost. So which one is going to give me the minimum?
The last one.
The last one, minimize. Okay, so this is my min. So what's going to happen? What do I want to do if I'm going to minimize cost? This coordinate is going to give me the minimum cost, which is going to mean what? What does 1,200 comma 800 mean? Like, what does that do for me?
It's a spot on the graph.
It's a spot on the graph, but what does it mean?
Don't know.
1,200 what? 1200 is what?
What?
The year.
What's
Basic.
the basic? I'm going to produce 1200 basic iPhone docks or whatever they are, phone docking stations, and 800 multifunction. Is it multifunction? That's what they're called.
Yeah.
Multifunction.
I accidentally said multi-station.
Multi-station. So that's how many I'm going to produce in order to minimize the cost that is going to take to produce those. Does that make sense? Research and development, they have to do these kind of a lot. Although the computer system usually does it for them, right? They'll say the trend of how much this is costing me is this much. How much of each kind am I going to produce?
Who is that?
Right? So there's that.
Me.
Questions? Good? All right, you have a worksheet for homework. Everybody say bye.
Bye.
Bye, strangers.